Did that work for everyone? Okay.
Yeah. So, okay, cool. Yeah. Text me if you need anything.
Okay, cool. Sounds good.
Bye.
Okay. Sorry, I've never used WebEx before. I'm new to this. Okay. Hi, everyone. How are you doing? Oh, okay. I'm hearing things. Okay. All right. So hi, everyone. I'm Lucia, and I'm going to be leading the Python workshop today. Okay. I see some stuff going on in the chat. Okay, cool. So yeah, I'm Lucia. I'm going to be leading the Python workshop today. I'm a rising senior at Stanford. I major in computer science. For my undergrad, I'm majoring in computer science with a track in theoretical computer science. I'm also enrolled in the coterminal master's program. And for the master's program in CS, I'm tracking in AI. So yeah, I'm going to be giving you guys a little tour of a Python workshop that I just wrote for everybody. Sorry, I was fixing some last minute bugs, so I was actually a little late to this because I was trying to fix it. Okay, let me see if I can, let's see, do this. Okay, so I'm gonna share my, let's see, I'm gonna share my GitHub link with everyone. So if you, did everyone see that? I just tried to send it. Okay. Can everyone see that? Okay, cool, awesome. Okay. So it's in the chat. So I think if you can't find it, you might need to open the chat. Also, for anyone who's just hopping on now, if you could mute yourselves for now, that would be really helpful if possible. Okay, awesome, cool. So let's just get started. Let's see. Let me see if I can share my screen. Okay, can everybody see this? Yeah, okay, cool. I see some people voicing in the chat that they can see it. Okay, perfect. Yeah, so this is sort of the Python workshop. I hosted everything on GitHub, and GitHub is basically a system that is used for storing code and keeping track of different versions of code. So it allows many people to access code and see it and run it and make changes if they really want to. It's really commonly used in industry. And so that's what I'm hosting the workshop on. Most of the reason I'm hosting it on here is just because it was convenient for me to be able to update code as I was going and to share it with all of you. But don't be super intimidated by the format. If you've never used GitHub or anything like that before, that's totally fine. So you have a couple options. If you are familiar with GitHub and sort of the mechanisms around this, then you can definitely download the code. So if you go to this button right here, this green button, then there are several ways that you could do that. So if you are familiar with terminal and cloning stuff, you can do git clone. I think I saw it in the chat, and then clone using the URL. If that's not something you're familiar with, no worries. You can also download a zip file that just will straight download everything onto your computer. So that is another option or a way to do it if you want. Okay, so I think somebody is requesting to annotate, but I'm going to decline that. Okay, so yeah, so these are the ways that you can sort of grab the code. Another option is, if you're not super familiar with any of that, that's totally fine. The important file that I'm going to be working with right now is this example task notebook, Jupyter Notebook here. It should load right in the browser. It's a little bit slow because there's quite a bit on it, but this is another way that you can sort of view what's happening, and this is much simpler than downloading it onto your computer. For those of you who are familiar with it, essentially once you download it on your computer, probably the best way to view it is I'm in my terminal right now, and I'm just going to go into my BridgeHacks repo, and then you can use the command Jupyter Notebook to open a Jupyter Notebook to open it in your browser. That's at least how I've done it, and I have that running in a file here. But again, no worries if you don't have any of this stuff. I think then probably the easiest way to just look at everything is to go to this link in and open up the notebook like in browser. To be able to see the information if you can't like download it or run it. Does that make people? I'm gonna pop up in the chat too just to see if people are making sense. Okay, so I guess were people able to get this at least? No worries if you can't download it. Okay, great. I'm seeing a lot of people say yes. Cool. Yeah, for those who are Jupyter Notebook locally, you can like open your Jupyter Notebook and you'll have it like running side by side, so you can have your own copy if you.
Oh, is this a Cisco thing? Yeah. Is it free?
Somebody else is requesting to annotate my shared content, and I'm going to decline again. I'm not sure why so many people are requesting, but yeah, it's up to you. Yeah, I'm hearing some things that is like it's taking forever to clone due to large CSV. Somebody is requesting to annotate again. I'm not exactly sure why. Okay, so yeah, no worries if it's taking a long time to clone. You don't need to like run through it. Where do you go? Okay. So go to this link. So I'm seeing a question is what does clone mean? Clone essentially means that you're going to copy all the files that are on the GitHub repo into your local computer. That's sort of what clone means. But you need to have GitHub set up to actually do that. So again, my preferred method for everyone is probably this. Somebody asked, what is a GitHub repo? Yes, so GitHub repo is a place where you can store code. Git is a tool that you can use to sort of store code and edit different versions of it. Yeah, somebody's also asking if you can use Visual Studio Code. You can use whatever you want to open this. I wrote these things in Jupyter Notebooks, so I'm going to use Jupyter Notebook to run it. But for those of you who like understand beyond that, you know, feel free. I think the easiest way is probably go to this link that I shared in the chat, and then open just that file. So literally open it in the browser. You should be able to see it in the browser. So you don't need any special tools to do that. So I would say that's the easiest way to go about that. Okay, great. So yeah, one thing, yeah, you can use whatever you want. There are ways to convert this file into a Python specific file, and so you can run Python in it. Okay. Somebody keeps requesting to annotate my screen. Whoever that is, if you could please clicking that button, I think it keeps coming up on my screen. Okay. So yeah. Oh. Did everything just stop sharing? Oh. Can anyone see my screen?
No.
No, I can't.
Everything stopped. Okay, I don't know why.
You need to turn off screen sharing.
Okay, I'm content thing and it's not working. Okay. I don't know why it suddenly stopped. Oh. Okay. Can you all see it now? If you can go into the chat. Yes, okay, sorry, I don't know what happened. It just stopped all of a sudden. Okay, oh. Okay, whoever, I think it might be because somebody else is trying to share screen. If you are if you're not presenting, can you please try not to click the share content button? I think it interferes. Okay, great, awesome. So I'm gonna open the chat, and so probably the easiest way to communicate with me is through the chat. Okay, so I see a lot of questions in the chat right now about, okay. I'm seeing a lot of questions in the chat right now about like what to do with the file. Again, you don't have to worry about it. That's just for anyone who's already familiar with it. If you're not, I would suggest just going directly to the file. No need to download anything. I'm also seeing a lot of other questions
My
about
fingers still
that
hurt.
you can run.
Just so you know, it hurt my hand more than it.
But those are not super important for now. So yeah, let's just walk right into the workshop. And as I explain things along the way, hopefully it'll answer some of your questions. And then we can get going. Yeah, so in this Python workshop, essentially, we're going to walk through some useful building blocks for making pipelines and experimenting with data. And so there's a couple of notes here. These are mostly about setup. If you're trying to get this set up on your local machine, maybe after the workshop, these are some helpful tips for getting it started. There's many things that you might need to download in order to have this work on your local machine. So again, if you can't get that working right now, no worries. There's an entire notes section for things you might need to download onto your computer in order to get this to run. So I thought a good way to introduce everyone to Python was to walk through an example workflow for a machine learning task. And so through this task, we're going to see different packages and libraries that are going to be useful in Python for doing like a prediction task. And so this will teach you a little bit about like how you get data, how you write code to sort of clean up the data, how do you, train models, how do you test models that you might want to make. I see a question in the chat, which is, what is machine learning? And machine learning is essentially a field of artificial intelligence, and the field as a whole is sort of aimed around getting machines to be able to achieve some level of human intelligence, essentially. And so the point is often to use data or other artifacts to predict things and find patterns within data that might tell you something that you would otherwise be able to learn as a person looking at something. And it's often helpful or used in the context of the areas where there's a lot of data or where a human might not be able to, identify patterns quickly. Yeah, so for everyone who's asking questions in the chat, these are really good questions. I'm going to be walking through a lot of these, but for now, I think unless if I haven't gotten to that section yet, hopefully I'll be able to answer the question in that section. I'm seeing another question, which is where is this document? So I'm just gonna link it again. Okay. So that is the link if you need it again for getting the document. So today, the machine learning task we're going to be working on is a binary classification task. So essentially what that means is we want to predict whether a news article input is in one of two classes, either true news or fake news. And this kind of task falls under a subdomain of artificial intelligence and machine learning called natural language processing or analyzing natural language. And essentially the goal of the task
can you mute yourself?
The goal of the task is going to be to take a bunch of articles from the internet that are news articles, and we're going to analyze the text in these articles, and we're going to predict either that the article is a piece of true news or that the article is a piece of fake news. And the reason that I chose this project was because I feel like this project is very pertinent to sort of what we're doing in this day and age. A lot of the issues that are going on in this day and age around misinformation and fake news and things like that. So I thought that this would be an interesting project to do. So the data set I grabbed is from a site called and so Kaggle is essentially a site that a lot of machine learning engineers and other people use. You can find a lot of data sets on here about a lot of different things that are pretty cleaned up and that you don't have to do much to get into a good state. So I'm seeing a question, what is a data set? So essentially a data set is some file that contains data or examples of a certain thing. So in this example, the data that it has is it has data that shows the text in news articles, and then subject or date, and whether the news is true or fake news. So you can find a lot of data sets on Kaggle. And so if, yes, the huge CSV files were the data sets, exactly. So you can actually download the data sets, which are CSV files, here and download them onto your own computer. You could do that on Kaggle for any data set you see, and it's something I really encourage you all to explore. If you're interested in a data-related project for this hackathon, Kaggle is a great place to get data sets. And so that's where I got this data set. And some citations of the people who put together the data set. Awesome, cool. All right, so now on to pre-processing the data set. So we're going to start off, we're going to import some packages and libraries to pre-process our data set. So here are some of the libraries we're going to be using, and I'm just going to introduce some of these. Okay, I'm seeing a comment, I keep getting a comment privately about downloading the repository and getting an error about git LFS. If you're getting that, that's because the CSV files are really, really large. The data files are very large, and you might need an extra plugin to get everything functioning locally. So yeah. Adrian, right now what's happening is we are going to this link if you want to see sort of the code for this workshop. Here, I can put it in the chat again, and we're just going to go through sort of this workflow. Do you have a specific question you're confused about? I'm not sure. Okay, so first, we're going to pre-process the data set that we just got from Kaggle about all of this news data. So some of the popular libraries for doing this I listed here, and you can go explore these a little bit more on your own later. So somebody in the beginning asked, what is Pandas or what is Numpy? So these are popular libraries that are used for working with large amounts of data. I tried to link all the documentation for any library I mentioned in here so that you guys can also go on the internet from these, like you can just click on it from the Jupyter Notebook, and it will take you to that. Maybe you want to open it in a new tab though, so that you don't leave this. Sorry, that was my bad. I didn't realize that would happen. Okay. Sorry about that. Okay. Yeah, but you can click on any of the links to get to any of these documents that will give you more information about these different packages. So if you have any questions about those, first of all, I'm happy to answer anything, but also they're up there if you're interested in exploring them further. So the first thing I'm going to do is I'm importing a lot of these packages. And you can do that in Python by doing import and then the name of the package. And if you see something that says like as something else, this just gives the name, it gives it a nickname that you can refer to it by that's a little shorter. So that's sort of what's going on up there. And the first thing we're going to do is we're going to read in the dataset files. So I'm using this library called Pandas for this, and Pandas has a function called read CSV. Call pandas.csv, and then you give it the name of a file. Then, yes, this is a Python workshop, yes. Then you can read the data from a CSV file. So the CSV files, again, remember, the really, really big files that hold all the data here. It's just another format that the data comes in. And I have a comment up here that says these functions read the data set files into data frames, and you can think of them like gigantic 2D arrays for data. Essentially, you can anything from a CSV file into one of these gigantic dimensional arrays. And so it's sort of like an array that holds all these different rows in it, essentially. I'm seeing a question, what is the advantage that NumPy arrays give over two-dimensional Python lists? That's actually a really good question. So if anybody has a question, always feel free to ask. For anyone who maybe is a little confused right now what's happening, I'm going to try to address all the questions regardless of what level they're at, whether it's from somebody maybe with a little more experience versus something that's a more, okay. I don't know why this keeps happening. Why does this content keep stuff? Like, why does this keep happening? Okay. The question in the chat was, what is the advantage that NumPy arrays give over two-dimensional Python lists? And again, I'm going to answer all questions. I would say that's a question probably asked by someone with a little bit more experience with this, but I am going to answer it just to answer the questions. So essentially, I think Kevin started an answer as well, which is it's faster, and that's definitely true. One of the advantages of using the NumPy package over a two-dimensional list is that oftentimes the NumPy version is more optimized. So if you're going to do actions on the data that you need to do over everything, let's see. And okay, yeah. So if you are doing an action like maybe adding or filtering the data in some way, it is much faster to do it in NumPy than it is to do it if your data is in lists and things like that. It's helpful for me to mute all the participants to prevent people from sharing. Okay, so let me see if I can do that. Anyone immediately how to do that? Let's see. I have this format before. Okay. Sharing. If I can do this really quickly. Okay. Participants mute all. Okay, let's see. Participants mute all. Okay, cool. I just tried to do that. And then, is there a way to prevent everyone else from sharing? Let's see. Oh, perfect. Awesome. Thank you. Okay. Yeah, so let me continue with this. All right. It seems like there are some people who are a little confused. Again, I'm just going to try to go through the entire workflow. If there's a specific question you have, feel free to ask. If not, I just sort of am trying to lay out a lot of different things that you can use here. So no worries if there's maybe a little confusion about what's happening. You can always go back and look at the code. It's always going to be here. This is going to be recorded and the links. So you can always explore some of these packages on your own. Right now, I'm honestly just trying to introduce some of these ideas. Yeah, so essentially here we're reading the data from these two CSVs that hold the news articles that are labeled like true news, and then the ones that are labeled fake news into these gigantic array things that you can sort of think of just as like gigantic containers for your data. And so Pandas has this function also called head, and you can use it to show any data frame that you want and what is inside of it, or at least the first few lines of what is inside of it. So here I'm printing out the first couple of rows of the true data frame, which holds the true files, and we can sort of see that each of the rows is one article. There is a title, there is some text, there is a subject, and there is a date. So that sort of shows sort of what's happening in that file. And the false one would look very similar, but the examples would be the false examples. And so the next thing I'm going to do here is this little bit of code grabs the text column from the text of the, I see a good question. Are you able to use true.head instead of pandas.true.head? Yeah, so essentially, as long as the thing that you're calling .head on is a pandas data frame, like as long as you read it in some way using pandas so that it's a pandas data frame, then you can call .head on the data frame itself, like that. Yeah, so it's a method that you can use on the data frame. So this code right here is the list in Python similar to the list class in Java? Yes, so list in Python is really similar to a list in Java. Essentially, it just holds data of some type. So in this piece of code right here, we're sort of grabbing the text column of this data frame by calling true and then using these brackets, get the text column. And then we're turning these into Python lists, which you can just imagine as things that hold all of the text for each of the articles as elements, one by one. All right. Okay, I'm seeing a lot of concern in the chats. So I just want to address again, if you see that it says there's no module in some way, then, okay, let's see. So for Adrian, if you go to this link right here, and then you click on this IPy notebook here, then you can access this. And then for the other people who are trying to run this, there may be a module that you need to download. So again, don't focus too much on running it right now. Yeah, okay. So this code right here sort of just grabs the text that you're that is in this column right here. I'm also seeing a lot of requests. I think that people are just in general confused. I guess, is there something specific? Does anyone have any specific questions that you want me to address? Yeah, I welcome any specific questions. If you have them in the chat, just feel free. Yeah, so also, I think maybe carefully reading through some of this will help with some of the questions, in the sense that everything that is used is commented. So, or like there's text around it. So if you're confused about anything, you should be able to find a link to more information about it. Okay, so I'm getting a lot of questions. So Pandas is a library that you can use to read data. Okay, Numpy is also a library that we can use to access data. So there's some further information here. If there's something specific I can address, please let me know. So in the next here, essentially what we're going to do is we're going to tokenize the data. So one way of doing that is you can use this library to tokenize some of the data. So essentially what that means is we're going to take all of these strings that hold like all of this content from the different news articles, and you can split it up so that each token is like a word from the article. And so this bit of code sort of does that. And again, this is code that you can use if you want. So if you're doing a project related to text, then you can use this. And so this will allow you to create these tokens. And so the tokens are like individual words, essentially. Okay. Let's see. Okay, so, okay. I think for people maybe who are a little confused, who have never coded in Python before, this might be a little difficult to understand, just because if you've never coded in Python, it might be sort of hard to understand maybe the structures and things that are going on. But I think the purpose of this workshop, I did want to show some like maybe you wouldn't otherwise be exposed to. And I think there's stuff in here that maybe you would be able to reuse, even if you've never used some of the concepts before. There is probably some stuff in here that you could still like copy and paste and use. Let's see. Okay, I see. Some people are confused. Okay, this is an intro to Python work. Okay. I guess, okay, we have half an hour left. I don't know. If you would like me to keep going through this project, I can keep going through it. I think this is just something that was maybe a more aspirational thought. But I'm seeing a lot of complaints in the chat. So if that is true, but I'm also seeing a lot of people who would rather continue going with this. So I think maybe I'm just gonna keep going. And for those of you who, again, are maybe a little confused, please just sit tight. If you have specific questions, feel free to ask them. And let's see. Okay. So, okay, it looks like this chat is getting into a very interesting state. Okay, I wonder if there's a way to. So anyway, I'm gonna continue with this. Again, if you are confused, I think this is, maybe some of these ideas are a little advanced, but I'm hoping that maybe the thing that you'll get out of it is you'll be able to use maybe just one or two of these ideas to do a project. So essentially, something like this, I think that a lot of people could use. Like if you were to import pandas, it would only require like 3 lines. You would import pandas, and then you could call the line, and that would load data from a file, for example. So that's like something that you could just use quickly. So let's move on to the word embedding models. And so this is a cool idea. I think, again, something that may be a little bit more of a challenging topic, but I do think that given the libraries that exist for this, it might be actually like you can code in a couple of lines a word embedding model. And so I do want to show it to you, even if maybe it's something that is beyond the scope of maybe what you're currently exposed to or what you currently recognize. So a word embedding model is essentially a way to make some words into numbers. And the reason that this is important is because a machine cannot understand words. The only way a machine can sort of learn is to, okay, let's see. So Shrey asks, what is a tokenized word list? So essentially, a tokenized word list here, so this is some code for tokenization, and you can actually use it yourself if you want. Would literally just copy this directly and run it, and it would work on any strings. So like you can use this however you'd like. So tokenized word list is essentially a word list. Let's see. So for any, or yeah, so okay. It seems like some of you are also explaining to each other, which is great. So a tokenized word list is essentially a list of the words from a long string. So if you have an article and you tokenize it, and like say the article says like, "Hi, welcome to BridgeHacks," for example, then the tokens would be like, "Hi, welcome to BridgeHacks," and so on. Yeah. So the next thing I want to talk about is this word embedding. So essentially what this allows you to do is it converts words into numbers, essentially. And the reason that's important is because when you're building a model like this, you want to be able to have the input be numbers. A computer cannot understand how to train a model on like strings, for example. And so it functions best when there's like a numerical representation of data. And so we're going to create a word embedding model that allows us to take the words and actually make these like embeddings. So you would imagine like a word like hello would get mapped to like a whole list of numbers, essentially. And that would be true about any other word. So like goodbye would also be mapped to a different set of numbers. So that's what an embedding is. So embedding is a like list of numbers that represents a word. Let's see. Yes, the file is available for everyone after the workshop. So what method would it use to embed the words? Yeah, so let's chat about that a little. Probably this workshop that might confuse me, but essentially
720.
So essentially what's happening here is you can use these libraries that will allow you to grab models. So Gensim is an example of a library that allows you to grab pre-trained models. And what you can do is you can use this API here that we imported earlier, and you can see all of these different models. So an API is like a tool you can use to grab information. Does that make sense? How are numbers used to represent words in codes? Yeah, that's actually a great question. So essentially what's happening is the way that you get words and make them into numbers, which is like really strange sort of, or like a strange sort of idea, is that so the way that you can convert words maybe into numbers is that you can train essentially a model that predicts either the context of a word from the word itself or a word from its context. So for example, if you had words that were like hello and then something else, maybe a really common word after hello might be like a name, like Sarah or Bob or Tom. And so those are the words it would predict. And essentially, based on this model, you can create these lists of numbers that essentially tell you the likelihood that some word is surrounding a certain word, or that a word is surrounding a certain context. And that's essentially how these models are created. But basically, the code here will give you a model. So this code here will sort of produce for you a model that you can use for your words. And that's all that's going on there. I think somebody did say that this label should have been this workshop should have been labeled as intermediate, and for that I do apologize. I think I was under the understanding of preparing like a hackathon workshop, and so if this is like maybe a little bit too advanced for students who are like attending this hackathon, I do apologize for that. But yeah, so perhaps this should have been a little bit more of an intermediate thing, and that should have been clear in the beginning, because I do see a lot of confusion in the chat. All right, so for visualizing the doc embeddings, so I wrote some of this extra code. Again, these are things that the reason I'm putting it here is that you can use this bit of code without actually understanding how it works exactly. So you can use this as like a tool in your own code, where if you copy and paste it, and as long as you understand how to use it, it is not essential that you understand this particular bit of code. And so that's one of the things I really want to emphasize about some of this, which is even if the code itself doesn't make very much sense, as long as you know how to use it, then you can actually like copy it and, you know, use it in your own code, even if you weren't the one to write this, right? And so I think that's another key point here. But essentially what we're going to do here is I wrote these custom little classes, and essentially what they're responsible for doing is they're going to take some model. So these are the models that are pre-trained. You can sort of think of the model like an object. It's like this object with a lot of information in it that a lot of really smart researchers and scientists trained like all this information on to create all these mappings between words and lists of numbers. And you can use these models. And so essentially what's going to happen here is we're going to take one of the models that we downloaded, and we're going to fit all of our data. So all of our data is the text of all the news articles, and we're going to use this vectorizer to fit all of that data. And essentially what's going to happen is this creates a whole bunch of doc embeddings, and that means is we've successfully embedded each of the strings holding text for each of the articles as numbers. So now there's no more words and no more strings and no more like text from the articles. We've turned all the text from the articles into literal numbers that have meaning, that help us understand the words, but are in numerical form. I see some more questions. So is this model thing related to machine learning? Yeah. So essentially, a model can be like trained essentially to output these embeddings, and the whole point is to train a model so that the numerical representation, the embedding of a word, represents the word really well. So you would think that maybe like some of the, like if there were a bunch of words that were like pets, like cats and dogs and stuff, they'd all have like embeddings that kind of look the same. They all have like numbers that sort of look similar, or similar in some way, right? And maybe all the names in the world have like some similar numbers. All the foods in the world have some similar numbers. So there's like a way to train the model such that the embeddings really display something about the words themselves. How does this model make predictions for the context of the word based on their mapping? Yeah, so that's a really good question. So essentially, racing, what happens is the model takes in literally this huge corpus of all the data that is in the world that is written. So it'll take like all of Wikipedia or all of Google or something, and it'll put it in a model. And essentially what you can do is like, it counts the occurrences, or it learns patterns about like, where is hello used in sentences in general? Is it typically used with goodbye? Is it typically used with a name? And like, where is cat typically used with dog? Is it typically used with, you know, something else? And so that's sort of how it gets the insight about how to make these numerical representations or embeddings of the words, essentially. That's a really good question, though. And that's something that you can definitely delve into deeper if you want. All right, so then the next thing after that, after we make these embeddings, does everyone understand sort of that the embeddings are a number representation of the text of the articles? Okay. How would a number string of characters be represented with the model, a random string of characters? Yeah, so that's actually really interesting. Sometimes there's different ways sometimes that it can be represented. Oftentimes what happens though is it's sort of represented as the kind of word that the computer is unfamiliar with, or the model is unfamiliar with. Like it's like an unusual word, and it doesn't have very much context around it, or maybe it's not used very much, but there will be an embedding for it anyway if it exists out in the real world on the body of stuff that was used. So sometimes it will have like sort of a special kind of embedding, essentially. And so that was a great question. Okay, so yeah, I'm also getting some requests to slow down a little, which I will definitely try to do, but I think I only have until 7:30 as well. So I do want to get through some of this. Again, I'm happy to stay on and like answer questions for people at the end though. So the next part that we can do is we can use these embeddings, and we can do this thing called PCA. So PCA is, again, a little bit more of an advanced technique. I linked the PDF that might explain a little further, but the way you can think about it is like, imagine you have data that's in like 500 dimensions or 300 dimensions. It's like, how do you plot something that has 100 dimensions, right? Like we cannot see in 100 dimensions. We can only see in at most 3 dimensions, right? Or at least I hope I can only see in 3 dimensions, right? So one really cool thing is you can use this mathematical technique that sort of acts like something that is like a pancake. It like flattens or like smushes this really high dimensional word embedding with a bunch of numbers in it, like 100 numbers into it, into embedding with only 2 numbers in it, like a vector with only 2 numbers in it, or a vector with only 3 numbers in it. And the way it does this is sort of mathematical. So there's like some mathematical theory, but essentially the point is you want to retain the most meaning possible you can, but shorten the dimension. Yeah, Trey, that's actually a really good question. Wouldn't there be a loss of info? Yes, there is a loss of information because obviously you can't represent 100 degrees in 3 degrees. But the strategy that is used is the way in which you could possibly do this that loses the least amount of information, which is what is super cool about principal component analysis. Does that sort of answer that question? Yeah, so one that you can get these vectors in, is it something related to abundance? Yeah, a little bit, and something also related to just maximizing the variance that you can get in less dimensions. But again, this gets into a little bit of math that's probably not super relevant here. So now once you have these vectors, now we have these embeddings that are literally two numbers or 3 numbers long. And we can do these cool things where we can use this other library in Python called Matplotlib. And what we can do is we can make these plots of the data. So what we see down here is a plot of all the documents that are true and all the documents that are false. what it's plotting is the two-dimensional version of each article. So it's like each article has 2 points, like x equals -10 and or y equals 5 or something like that. And the color it's plotting is the label. So this label came from the files. And what's really cool that you can see here. So again, this idea, not something that I would necessarily say you have to, I would expect anyone to recreate, but this is just sort of like a cool idea I wanted to share that relates to a plotting library. Plotting means graphing, so showing something on a graph, showing something on a plot. And so here what's happening is we're plotting the 2-number representation of each of these articles. And you can see something really cool, which is that even in 2 dimensions, the word embeddings do pretty well. You can kind of see that the true is separated, right, by the color. There's a little overlap in the middle, but you can see that they're separated, right? And then the 3-dimensional version is even better a little bit, right? Like there's sort of a blob here, another blob here. And so that's one of the things that's really amazing about some of this, like these pre-trained models and these models that other people are working on to get words into numbers. They get you into, like you can see here by the visual that they have a lot about what's going on in the article, right? That even a 2-dimensional version of this, these embeddings can get you so much information about is this fake news? Is this true news? Which is really that in 3 dimensions.
Doesn't understand anything, right?
Okay. So the part of this little workshop is now we're actually going to train and test the text classification models. So remember, the goal of this whole thing was we're going to take articles in the wild, and we want to create a model that can predict by looking at the text of an article, is it true or is it false, right? And so we haven't done that so far. All we did is we made the text, all the text of the articles into numbers, right? But we haven't actually done anything yet. So now what we're going to do is we're going to take these numerical embeddings of all of the articles, and we're going to train and test some models to classify them. So that is what this little part is doing. And the library we're going to use for this is called Scikit Learn. And so this is a software machine learning library in Python. There's documentation. And so this is something else you can download and you can use by importing tools from this Scikit package. So the things that are shown here, there's a couple of different things. Here, there's a couple of pre-made classifiers that are available in Scikit Learn. And essentially what a classifier is it's a way or a procedure for identifying the patterns within some numerical input to classify each numerical input as one of 2 or many labels. So here the labels we want are true and like false, or true and fake. And so each of these is just a different way of doing that. I linked some extra stuff up here as well about what is the difference between some of these different methods, but I won't go into it too much here. Some little notes, like the support vector machine, for example, is a really cool one that essentially takes all this data that's in super high dimension and figures out a way to sort of draw a line through all the data that separates the things that are of one class versus another class, for example. All right, some questions. What is the pipeline function? Yes, so the pipeline function is a function that helps you construct a pipeline to actually process all the data. So the first thing in the pipeline is going to be, again, one of these vectorizers. So I'm trying to use a couple of different vectorizers here. These ones are ones that are available directly in the language, like inside. They literally count. They create the embeddings with the numbers in them by literally counting how many words of each type there are. So you end up with this really high dimension vector that's like, how many times was hello there? How many times was goodbye there? How many times was blank there? And so these vectorizers are a little bit more of a more rudimentary way of doing it, but I did want to test them just to show them to you. And then this second part is the actual classifier. And so this classifier will allow you to, is going to train on the data, and then it's going to create some sort of model that allows you to feed it more inputs, and then it'll guess the output. It'll predict the output based on the patterns it learned from the previous one. So that's what that is. This analyzer lambda thing you don't have to focus on a lot. This is essentially the function that teaches you or tells the computer how to process the input. And what this is saying is essentially that each row inside the data that is being fed is exactly what we want to put into the count vectorizer. So like each string represents an entire article, and we're going to take that string, which is every row in the data, and we're going to feed it to the vectorizer, essentially. And then here are some other examples. So these two use the vectorizer we created before with the that we created there with the actual model embeddings that are like downloaded from somewhere else. And so we sort of have this prediction that maybe these ones will do a little bit better than the ones that sort of just count how many words there are of a certain kind. Okay, so now that we have that, yeah, lambda is an anonymous function. Yeah, so for anyone who understands that, this is essentially a function, but you can sort of think of it as telling the count vectorizer how we're going to process the data. This is essentially saying we're processing the data row by row. Okay, so now that we sort of did that, the next thing we're going to do is we're going to split up our data. So the way that you typically would train one of these models is if you have a bunch of data, oh no, you're totally fine. The way you want to train a model once you have all this data from the wild is you want to separate it into training data and test data. So the problem is if you train on all the data, then your model has seen everything, right? It knows all the inputs, and it could literally just write down all of the inputs and like say, hey, I saw this input, and the output is something I've seen. So then when you test it, then it already knows all the answers, right? It knows all the answers. It knows if it's true or false or whatever else. And so instead, what you want to do is you want to split it into training and test data so that you have data that the model hasn't seen and data that you have seen. So data that you are training on, you're telling the model, hey, use the training data to learn the patterns. And then the data that you test on is data that you purposely don't let the model see. And then you can test the performance of your model on that. Okay, cool. So then once we do that, this last part essentially just takes all the models and trains all of them and tests all of them. So it takes all the models we built, like all the pipelines we built, and it runs all of those models against the data that we have, which are the embeddings that we created earlier. And then we can sort of score the models based on how well they performed on guessing the true and false labels in the test segment. So essentially what we do is we give each pipeline the training data, we throw it through the pipeline, it trains and learns some patterns, and then we take the test data inputs, we feed it through the model, we get the outputs, and we know the labels for everything, right? We know the labels for the training and the testing set. Those are all available in our original data set, right? And so now we can compare whatever the model guessed for the test inputs for their labels to the true labels. And then essentially what happens is it runs each model in a for loop, and you can see that a lot of these models actually have really high accuracy. And the reason is because some of the algorithms we're using here and the models we're using are pretty advanced, but essentially they all do fairly well. And you can sort of see at the end, this just sort of sorts and tells you which of the models is the best, essentially. Yeah, and that is pretty much everything that I wanted to show and the end of the workshop. If you have any questions, now is the time to ask. I'm helpful to stay on for a little while. I'm not sure if there's activities after this that people need to get to. But yeah, does anyone have any questions, any concerns? Okay, so could I go into the language itself? Okay, what do you mean by the language itself, Felix? Like Python itself? Yeah, so is there something specifically that you want me to show? So, okay. Um, hmm. Yeah, I think Felix might be a little bit too advanced for this. But yeah, I think maybe like honestly, I can also show some resources that are really good for introductory Python, and help people learn introductory Python. So one place is that I
Z07.
yeah, so one place that I know of is my school actually had this really introductory course for people who have never done Python before. I think, or no, actually, I'm not sure if this is publicly accessible. Okay, let me see. I think actually there is a version. This is probably publicly accessible. Oh, sorry. Let's see. And I believe this is taught in Python, and this is for people with no experience before. So it should be, oh, okay. So it should be accessible to people, but it includes a lot of really nice resources on introductory Python. And like it starts you from the very beginning from how to print something in Python. Yeah, this will be recorded. It is recorded, yeah. So that is a good resource maybe if you want to check out some of the introduction, like introductory material about Python. And there's a ton of resources as well in here about learning how these different libraries work. Yeah. Okay, any other questions? Where can we find the recording? I'm actually not sure. I will finish the recording after the session stops, and then I will give it to the BridgeHacks, like people who are in charge, and hopefully they'll post the recording somewhere. Can you explain Jupyter Notebook? It seems interesting. Yeah. I think Layla maybe? Yeah, so essentially Jupyter Notebook is just a cool tool you can use to run Python. And one thing that's really, really cool about it is that you can
2 minutes. Where do you join?
you can essentially run little snippets of Python. And essentially what you can do is if you like write in a Jupyter notebook, then you can write Python. And instead of writing an entire file of Python, you write it in little chunks. And essentially what you can do is this runs the first line, for example. And so it runs it line by line, and it gives you a sort of controlled way. So I just ran these 3 lines again. And it sort of creates a controlled way for you to run little bits of code one at a time, so that you can check the output of things as you're going and make sure you're not, seriously making really bad mistakes along the way. And the other thing it's good for is it saves your data for you in the notebook when you're running it. And so say you need to run something over and over again, and you need like a model that it takes a long time to download. Once you download it once into the Jupyter Notebook, it saves it and you can run it over and over again. Yeah. Shrey, what is a pipeline? Yeah, so for the pipeline situation, essentially, this is just something that you create to run your data through. So the first part of each of these pipelines takes the data and it takes it from words into numbers. And whatever is in the second part of the pipeline is the actual model we're going to train on. So we're going to train the data and create a certain type of model. And this is telling you the type of model. And so you build a pipeline, you can build a pipeline that does that takes all the word data, makes it into numbers, and then takes all the number data and trains it to create a model, essentially. And so that's what each of these pipelines do. Is there any tips or advice to learn Python on our own? So yeah, again, did you see the link earlier in the chat? I think there's a lot of people typing in the chat, so that might be hard. Let's see. I can try to put it in here again. That is just a link I shared earlier for an introductory class on Python that might teach. I think that should start teaching from the very beginning. And so maybe that's a resource that you can use for that. Yeah, cool. Any other questions? What are some other practical applications of Python? So honestly, this sounds kind of weird, but I actually think that like this application is one of the applications where Python is far like favored over a lot of other approaches. And the reason is because Python, there's a lot of libraries you can use to handle and wrangle the data. Another really common thing Python is used for in general is just to visualize things, like to look at things, like this, plotting this. Graph, for example, is another really common use of Python. You can build web applications in Python, but I wouldn't say it's something that like people do a lot. I would say generally people use Python for like simulation, modeling, and data wrangling, essentially. As you can do a lot of things in Python, but it's just like, I feel like most people, if they're writing a web page, would not choose to do it in Python, for example. Yeah, so a lot of like more mathy, sciencey things, I would say people do in Python. Yeah. Is this just the teeny part of an entire language? Yes. I think to actually learn Python, you're not going to learn Python necessarily in a day. It's going to take a while. These are just some libraries you can use for doing different things. But if you want to learn everything that there is possibly to know about Python, then like honestly, probably I don't even know everything that there is in the language, right? And so that is just something that there's like a lot of words essentially in the language, and so it's almost like you would have to take a long time to know all of those things, I guess, or to learn all of those things. Yeah, okay, I see some more questions in the chat. Can you tell me a little bit more about how you started programming? What was the graphing and plotting a part of the Numpy, and then how you got here? Okay, so Sarah, for the graphing and plotting, that was actually part of a library called Matplotlib. So in Python, a really common library for doing all this data visualization stuff is Matplotlib. I have it linked right here, right before the actual plotting starts. And so that library will be really helpful if you have any data and you want to visualize it. Yeah. And then for the other student who asked about how I started programming. Yeah, so I pretty much, my introduction to programming was pretty informal. In high school, I didn't actually have any programming like class at my school. So the first language I learned to program in is R, which is also something that is kind of weird. And so essentially R is another programming language that's good for working with data. And the reason I learned it was because I had a job that required me to process a lot of data. And so I sort of just like tried it out because I needed it for a job. And then I got to college and I just took some computer science classes, and that was sort of how I got started in there. Are all the libraries open source, or do we need to pay in order to use them? Yes, all of them are open source. All of them you can download for free onto your computer, no charge to you. There's not a single thing used in this workshop that I just showed that you need to pay for. Where do we find Python libraries? Yeah, so all of the links, every library that's used in this workshop is linked in the Jupyter Notebook. And so if you follow the link, then you can just download it directly. The website will give you instructions, specific instructions on how to download anything that I've shown in here. Yeah. Any other questions? Otherwise, I think people are slowly trickling off. So feel free if you need to head out, but otherwise I can stay and keep answering questions. Do Python libraries have information on their source code? Yep. All of these libraries are really widely used, well documented, and most of them are completely open source. So you can see all the source code for anything. And if you feel empowered, you can even make your own changes if you want. A lot of these libraries are really collaborative, have really strong open source culture, and so they do share a lot of their source code. Yeah. Any other questions? Say I want to do a project using TensorFlow. What platform do you recommend? Jupyter still? That's a good question, Christopher. There is a thing, I think it's called a Google Colab notebook. It's very similar to Jupyter Notebook, but it's like you can sort of get your own, a lot of these things with TensorFlow and stuff, which is another library that for anyone who's still here, it's another library that is really, is used for machine learning and often for training models that are really, really data intensive and really, really resource intensive. Sometimes Google Colab Notebook is a good choice to use because you can purchase sort of resources, you can purchase resources that allow you to do the computation, which might be better than running it locally on your machine. So I might suggest Google Colab Notebook. I've seen a lot of people use that, Christopher, but Jupyter is also still usable. I think you could use Jupyter to do it depending on how big your data set is and how many resources your code ends up taking up. But yeah, the other thing I would recommend is Google Colab Notebook for you. Yeah. Do you know an IDE or interpreter that doesn't need you to download modules like Pycharm? Okay, Pranav, so that is actually a really, really good question. I didn't realize that Pycharm requires you to download modules. That's really annoying. I didn't know that. I downloaded Pycharm at one point, but I don't heavily use Pycharm, so I didn't know that. Sorry about that. Yeah, honestly, the way that I write code is I just have Python downloaded and I download all my modules on terminal, and then I write in a text editor like Sublime that's really lightweight and doesn't have any, like, doesn't require an interpreter and like all of that stuff. So the way I would suggest going is maybe downloading Sublime text. Essentially, Sublime is a super lightweight editor that's basically like a Word document for code, and you just write your code in here. And what I do is I manually open up a terminal and I like run it in terminal. So I run it here, and that's typically how I work. That might work for you. Another option is there is this site called REPL.it that allows you to run Python in the browser. So if you want to try that, you could try that. Those are sort of some of my suggestions. Honestly, I'm not a big fan of heavy like IDEs, and so oftentimes I don't use them very much, so I don't have that much knowledge on other ones. Yeah, cool. Adrian, yes, REPL.it. But that was a really good question, Pranav. Yeah. Okay, Shrey, so what is Gensim and what is PCA? Yeah, so Gensim is a library that basically hosts all of these packages, or sorry, all these models that are created and trained by like top machine learning and like research scientists and researchers in the entire like world, essentially. And they're just kind of ready for you to use. Like Gensim sort of stores them, and then you can download them and use them however you want, which is sort of one of the other beautiful points about Python and about you know, coding in the modern age. It's like people are willing to share their results and really want you to be able to apply just like sort of top of the line, really novel new stuff that's coming out. So Gensim is a library that helps you do that. It like has models in it, and it allows you to sort of get models that have been like professionally trained on a lot of data and use them for yourself if you want. And then Shrey, what is PCA? PCA is a principal component analysis. So I did link a little like paper on that as well here before we actually use the PCA in the notebook. And essentially what that is it is a technique that is used to make really data that is really high dimensional. So like if something has 100 dimensions, you can't graph it, right? Like if it's like the coordinates are like 1, 2, 3, 4, 5, 6, 7, 10 to 100, you can't like graph that, right? We don't live in like an 100 dimensional world. And so often the way that we can look at data is only in 2 or 3 dimensions, right? It's like we can't really go higher than 3 dimensions when you're graphing something. And so because of that, PCA helps you essentially like flatten data that is like just like, you know, 100 dimensions or 100 degrees into 2 or 3, and it does it through a little bit of math. So we talked about this a little earlier. Somebody asked a good question. Don't you lose data when you go from 100 dimensions to 2? Yes, you definitely do lose data. But the PCA does it in a way essentially that loses the least amount of information while getting the numbers from 100 dimensions down to 2. And so you can call PCA on things using, I think this is the Scikit-Learn library. Yes, you can use from scikit-learn.decomposition import PCA. And if you PCA anything, you can get it from any number of any dimension to any smaller dimension. So you would literally then just write this line of code to however many dimensions you want the new things to be in, and then you'd call fit transform. And you could even try this on like a plain list in Python. Like if you had a list that was just 100 numbers in it, you could see it being reduced down into 2 dimensions using PCA. All right, looks like I think slowly people are trickling off, but if anyone still has any questions, happy to answer them. Okay, cool. It looks like, how does PCA's algorithm work? Yeah. Yeah, it involves a little bit of math. Essentially, this idea, this honestly might be a little bit complex, but essentially what it says is that when you have all these rows or columns of really high dimensional data, you can separate them into these really fundamental or primitive forms. And essentially you can write all of them in these things we call basis vectors. So they're like vectors that are, get the pick out the most essential part of the information of the different vectors that you of the really high dimensional data you have. And then what happens is it's sort of the actual small embedding that you get is like a weight of all of the bases. Like it's a weight of all these long vectors that you had. And when you weight each of the long vectors by that number, when you add them up, it will create the original really long high dimensional vector. So like the way you might imagine that is like if you had an 100-dimensional piece of data, and then you had two like basis vectors that are both 100 long, and then you add two weights on them, it basically finds the two really long vectors and then the weights that most closely can approximate each of the true 100-dimensional pieces of data. And then it takes those two weights and makes that the 2D vector, essentially. So a little bit of a complicated idea, but there's a link to more information on that if you're interested. Yeah. Let me see, sorry. Weights as in, yeah, so it's sort of like if you think about it like this, like say you had a one vector that was like, so say you wanted to go from 3 dimensions to 2 dimensions. Stay safe, have a good day. Awesome, thanks Chris, see ya. So you could think about it like this. If you had a vector that was like 1, 0, 0, and another vector that was like 0, 1, 0, and then you wanted to create the vector 3, 0, 0, what you could do is you could weight the first vector by 3. And so when it multiplies against the 1, 0, 0, you would get 3, 0, 0. And you could weight the second vector by 0 because it's like you don't really care about the middle part. You don't care about the 0, 1, 0 because your final vector is 3, 0, 0. So you don't care about that middle dimension. And so you can just zero that one out. And then basically you get two weights. You get 3 and 0. So the 3 interacts on the 1, 0, 0, so that gets you 3, 0, 0, and the 0 interacts on the 0, 1, 0 to get you 0, 0, 0, and when you add them together, you actually get 3, 0, 0, and so like you can see that you can sort of express 3, 0, 0 with just the two weights, 3 and 0, as long as you pick the other two vectors, the 1, 0, 0 and the 0, 1, 0 correctly. And so the point of PCA is it helps you pick for a bunch of data in a high dimension, the best ones of those basis vectors to use, and then the best weights that you can get to sort of get as close as you possibly can to the original vector, essentially. It's a little bit confusing, but yeah. Do I need prior linear algebra knowledge to understand this? A little bit. I would say though, like as long as you understand how to multiply like a number by a vector, then I think you could understand it in the sense that like if you understand that 3 times the vector 1, 0, 0 gets you 3, 0, 0 because the 3 acts on all 3 of the elements, then I think you can understand the basics of it. But there may be some wording in it about like other things like singular value decomposition and other things that require a little bit more linear algebra knowledge. But the basic idea is it creates these key vectors that are in the same dimension as the original vectors, and it figures out what weights to put on them to get as close as possible to the original vector, but you're only allowed to have the amount of weights that you want the new embedding to be in. So if you want everything to be in 2 dimensions, you're only allowed 2 weights and 2 special vectors to get all the original vectors. You can't have like 3, for example. You can only have 2. That's sort of the basic idea. Yeah. Cool. Anyone else have any questions? What are special vectors? Yeah, so again, yeah, so the more special vectors, it uses a little bit of math to figure out what the special vectors are. It's the special vectors that get you closest as possible to all of the original data. So if you have like, 50 long high dimensional vectors, it tries to figure out the best special vectors that you can weight to get as close as you can to all of the 50 really high dimensional vectors, essentially. More general question from Vincent. How should you apply your coding skills in high school? Yeah, I don't know. I think maybe like what everyone always says, which is just to create your own projects or do things that you think are fun. Yeah, I think one thing that is cool is like, for example, on Kaggle, which is the website I showed you guys earlier for getting data sets. There's a lot of really cool projects that are done on here, and the code is always publicly available to everyone, no matter like who you are. And so essentially, like there's like this COVID Open Research Dataset Challenge, and there's like tons of projects on this, right? Tons of people who've submitted work that's public on this. And so you can look at all their code and all of their results and maybe just try to do the same thing as them, right? Like try to, look at the code they wrote and try to see if you can recreate something like that to learn a new library or a new idea, for example. I think that could be a good way to go about that. I can put this link in the description, for example. Yeah. Does that help, Vincent? I would say other than that, like you can brainstorm your own projects as well. Like if there's just something you're fascinated in or interested by, then you can try to, pursue that or work on that. I would say that's probably the best way. I think oftentimes in high school, no one's going to give you anything specific to do, but if you go find something for yourself, you can create some pretty awesome things. Yeah. Anyone else have any questions? I think there's still 9 of you hanging on here. So if any of you have questions, again, really happy to keep answering them. Sorry if this was a bit of an overwhelming workshop, but yeah, really happy to chat with any of you, even one-on-one, if you want to unmute yourself and ask questions, or in the chat, whatever you want. I'm gonna stop sharing this, but I already know machine learning, but okay, let's see. Let's look at the chat. I already know machine learning, but where can we learn more? Or I already know Python, but where can we learn more about machine learning? I think, let's see. So there's an intro to artificial intelligence class at Stanford as well, that I have a link to that might be useful to you. Essentially, that's our intro AI class at Stanford. And so if you are interested in this sort of material, maybe that is accessible. I honestly say the notebook that I prepared, there's a lot of links to maybe helpful resources to read about different things like certain models, word embeddings, like how to train a model, that sort of thing. And so if you want, you can also go back to that notebook and try the links. Adrian, were you able eventually to get access to the notebook? I know you were having some trouble in the beginning. I'm not sure, but yeah. All right, any other questions? Otherwise, I'm gonna stop the recording and head out. What happens in the big section below the word embeddings? Okay, I guess maybe this requires sharing again. Let's see. Okay. What happens in the big section below the word embeddings? Okay. Are you talking about this section, Shrey? Is this the section you're talking about? No. Under? Keep scrolling. Yes, no. Is this the section? Further up. Okay. So before the embedding. This section? Bye, Adrian. Okay. Yeah, so Shrey, to go over this again, essentially what's going on here is we are taking so what's happening at the very top is it's taking the data from the original articles. So this is the text of the original article, right? And so then what's happening here is it's splitting up that text into tokens that are words, so just individual words. So for example, the text here is like, the head of a conservative whatever, like this is a very long paragraph or a very long article stored as a string. And essentially what this glob does is it takes like that really long thing or like a really long story or really long article, and it literally just like chops it up. So like if the first sentence is like, hi, welcome to BridgeHacks, it'll become like one string that says hi, another string that says welcome, another string that says to, another string that says BridgeHacks, and so on and so forth. And that's essentially what this does. Yeah. Cool. Yep. All right. What about the section that says Out 9. Okay, look. Out 9. This glob. Okay, so this glob looks way more complicated than it actually is. It's probably the least complicated part though, but it's just a lot of words. Essentially what's happening here is we're using this API that we imported earlier. So we're using this API right here from earlier that we imported from Gensim. And essentially what this is doing is this is showing you all the information about available models or data sets in this library that you could possibly download, essentially, is all that's happening there. And I'm just printing them out so that I can see them so that I can actually like pick one to use. Essentially, that's it. Yeah. API.info just shows you all of the models because I'm not sure what the models are. It is pretty cool though to follow this link right here. That will show you sort of the different models and a lot of really cool things about them, like, you know, this model's trained on all of Wikipedia, this model's trained on Twitter, and, you know, all these other things, and like where the data sets are from. Like it tells you a lot, like first, you know, however many bytes of Wikipedia, patent grant full text, like all sorts of other really interesting things. So this is just a really interesting link to go to, but essentially the api.info prints out some of the information from here so that you can actually grab the models. Yeah. Does that make sense? Yeah, thanks, Trey, for staying and asking a lot of questions that you're interested in. These will all go in the recording as well, so for anyone who's watching them later, maybe they'll help them. Yeah. Any other questions? Cool. Is there any way to ask questions after the meeting? That's a good question. I'm going to be like generally available this weekend if anyone wants to ask me questions, but I'm not sure the best way to go about like communicating that, like whether I should talk to the BridgeHacks students who are organizing, hop on a Slack, maybe. I'm not exactly sure, but I'm generally available this weekend, so I can answer questions sort of asynchronously throughout the weekend if there's something that sort of comes up. Yeah. Yeah, but I will definitely try. I can contact the student organizers and see if there's like some channel on which we can communicate more. Yeah. Cool. All right. Everything from everyone. I don't know, to the other students, if anyone else has any questions. Yeah, for sure. If anyone else has any other questions, feel free to ask. Otherwise, I think Trey has been the only one asking questions, so I'm going to assume that there's no more questions, and then I will hop off. But Trey, yeah, I will try to communicate with the organizers and see if there's a way to get on a common platform. Do you know right now if there's another, like, how the other mentors and other people are communicating with you all? They're communicating in a Discord server. Okay, yeah, maybe I can just hop on the Discord server then. Yeah. Okay, cool. All right, thanks everyone. I'm going to stop the recording and then head off. Let's